Alright, welcome. This is CS-211 SPARC. We're going to briefly go over Chapter 2, and this is in supplement to the PowerPoint slides, so you should definitely be looking at those. But this is just a brief overview of the major topics for those who find videos helpful. So we're going to go over if, else if, and else. We're going to go over switch statements. We're going to go over while, do while, and for loops. And we're going to go over primitive arrays in Java. So let's get right into it. If, else if, and else. So if, as many of you are coming from a Python background, you probably know if, elif, else very well. In Java, it's almost identical, except instead of elif, we have else if. The Java developers didn't feel like shortening it, so they just kept the entire else if. Behavior-wise, they behave the exact same. So on the left here, we have our very basic if-else block, which says, if something is true, do this. Otherwise, do that. Simple enough. On the right, we have an if, else if, else block, which as in Python would have been if, elif, else, and it behaves the exact same way as in Python, which says if something is true, do this and ignore the rest. Otherwise, if that's not true, check this next thing. If something else is true, we can do that and ignore the rest. And if neither of these are true, we're going to do this third thing. And it's as straightforward as that. Switch statements. Okay, so let's ignore what we have on the left here for just a moment. Imagine you have this situation. You have a variable x. It's an integer. Let's say we don't know the value, but in this case we'll make it 3. How would you find what the value of x is? A lot of you might think, oh, we'll just use a bunch of if, else if statements until we figure out what it is. If you were to do that, you'd have something like, hey, if x is equal to 1, do something. Otherwise, if it's equal to 2, do something else. Otherwise, if it's equal to 3, do something else. And then otherwise, if it's none of these, do a fourth thing. Now this structure we have here of trying to determine what x is something that's popped up so much in programming that developers of Java and other programming languages actually gave it its own special statement / structure. And here we have switch. Switch basically does exactly what we did here. And so let's look at the exact same situation, but if we did it with a switch statement. Imagine we had that same integer x. We're going to give it the value 3, but we don't know for a fact that it's actually 3. We want to figure out what x's value is. So we'd say switch on x. All this is saying is we're going to be looking at the value of x in the context of a couple of different cases. And whichever of these cases is true, whichever value x actually has, we're going to do certain things because of it. So we start out with switch x, got the brackets as if with if else, and then we'll have these cases. These cases just say, hey, do we have the case that x equals 1, or the case that x equals 2, or the case that x equals 3? That's a fancy way of just saying, is x equal to 1, is x equal to 2, is x equal to 3? And for whichever one of these is true, we're going to do something, and then we have this key line break. The reason we have break says that in switch, the way it behaves is if one of these cases values is true, so in this context where x is equal to 3, this case would happen. If you didn't have this break statement, it would do what's in case 3, so do both as it's written here, and it would also do any case that's after it. So break just tells Java, hey, I'm done here, get out of this switch statement. I've done what I wanted to do, I just leave. And then you probably notice this default statement. This default statement behaves exactly like an else statement, which it just says, if all of these cases actually are not true, they don't evaluate as true, just do this by default. It's the default action. Now I've drawn some lines here and some arrows to indicate how they're actually very comparable because they behave identically. This case 1 block does the exact same as this if statement. Case 2 block, same as this else if. Case 3 is same as this else if. And then this default does the exact same as this else block. So honestly, it's up to you as a programmer which one you prefer, which one you find is easier to write. But it is very useful to know this because in some contexts you might find this is easier to do. In other, you might find this is easier to do. This x that we have here, this value that we switch on though, you have to be careful. It has to be some kind of primitive value, like an integer, a character, a boolean, even a string as of recent Java revisions. So just make sure you put something primitive here, a variable that can have a primitive value, then you can do this very easily. While, do while, and for loops. Again, assuming you're coming from at least some kind of background, probably Python, you're aware by now how a while loop works. We have this initial condition, we have this quote-unquote guard expression, which is to hopefully make sure we don't have an infinite loop. We have something that we're doing inside the loop. Then we have this updating statement, which is aimed at taking the initial statement and bringing it closer and closer to the guard until eventually we just stop the loop. Now, if you have this kind of while loop, which has a initial statement, a guard, and an updating statement that are all the same, like none of them depend on if statements or anything, a for loop might be a more clean or concise way of accomplishing that. Because a for loop takes the initial statement, the initial condition, this guard statement, and this updating statement, and puts it all into one line at the very top. So this arrow is to show that these two behave identically. So if you have this while loop, you can write it like this for loop, which just says for, put your initial condition first, followed by a semicolon, then your guard statement, followed by a semicolon, then your updating statement. So in this case, we have the counter equals 0 is here, the guards right there, counter's less than 10, and then counter plus plus is here. Now, if you come from Python, you might not know what this plus plus means. You probably do recognize if I've written counter plus equals 1, which just says take counter's value and add 1 to it. That's a shortcut for even writing counter equals counter plus 1. Java developers and developers of other languages came up with another shortcut, a so-called shortcut to a shortcut, where instead of having to write counter plus equals 1, you can just write counter plus plus, and that just says take counter's value, add 1 to it. That's it. You can also do counter minus minus, which is the opposite. It subtracts 1. But those are the only two shortcuts of a shortcut that you can actually do. So you might find that more convenient. And also finally we have the do while loop. We covered the while loop, the for loop, now do while. Do while is 99% the same as a while loop, except it guarantees that it will iterate the loop at least one time. It says do what's in the loop first, then check the statement. So if you have some kind of situation where you know you want to evaluate and do the loop one time at least, regardless of whether the guard is true or false, a do while is what you need, because this will literally take, even if counter was 11, where this would evaluate as false, it will do this at least once. It'll go through, do it, it'll come out to 12 after this, and then it'll see this as false, and then it will exit. So if you know you need your loop to happen at least once, do while is your helpful tool here. And finally, primitive arrays in Java. As I've said until now, if you're coming from Python, you probably remember lists as being your friends, and lists are very nice in Python. They're also in Java, but arrays are not lists. They behave very similarly like lists, but they have a few very, very key differences. This is one of them, and I'll get to it in a second. Now, if you want an array in Java, an array is like a list. It can hold multiple elements in a single container, quote unquote. So, how do we create an array? Well, if you want to create an array, that array has values in it that you know what you want to put in it just to begin with, you can say, hey, Java, I want an integer array. We signify array with these two square brackets that are empty. So we say, I want an integer array. I'm going to call it x, and it's going to hold these values. That's fine. This line on its own will create an array that holds these four values. Now, in Python, you had the length function. In Java, you have the same thing. It's just slightly different looking. instead of length and like parentheses, the name of the list, in Java you have x dot length. That will return the length. So in this context, x has a length of 4. And just like in Python, indexes work the same way. The first element is a zeroed index, and you can access it using square brackets. So x of 0 in square brackets is equivalent to 1, x of 1, 2, so on and so forth. Now let's say you want to create an array, but you don't have any values to put in it to begin with. That's totally fine. You can do that. You can create a quote-unquote empty array. We start out the same thing on the left side. We say, hey Java, I want an integer array called x, and it's going to equal a new integer array of size 4, or whatever you want the size to be. It could be 2, it could be 4, it could be 100. Doesn't matter. The whole point is the size goes inside the square bracket on the right side of this expression. And again, just like above here, x.length is also equal to 4, just like it was before. Except here now, x, because you created essentially an empty array, Java is just going to populate the array with as close to a value of 0 as possible. So if you have integers, it'll be 0. If you have doubles, it'll be 0. If you have booleans, it'll be false, and so on. Now, that also brings up a point, how you might have noticed, I have integers arrays, I could have had character arrays, I could have boolean arrays, but notice how we had to tell Java that this is an integer array, or maybe a boolean array, or a character array, or a string array. In Java, an array can only hold one data type and exactly one data type. You cannot have, like in Python with the lists, where maybe the first element is 1, the second element is a character C, the third element is a string hello, and the fourth element is a boolean false. You can't do that. You have to figure out what data type you want to hold in the array, and you have to stick to that exact one data type. That's one restriction that's in Java that you didn't see in Python. Another restriction, remember how I said that arrays are like lists but have a few key differences? Another huge difference, and I cannot stress this enough, an array has a fixed length. It cannot change length unless you recreate the array in its entirety. For example, in Java, or rather in Python, you could do like if we had a list called x.append, and you could do that as many times as you want, and it would get progressively bigger and bigger. In Java, if you told it it can only hold 4 elements, it will only hold 4 elements. You cannot make it hold 5 elements or 6 elements until you recreate the array, which would make the array empty again. So, if you don't know what you're going to be storing, like how many values, err on the side of more rather than less, because unless you want to have to deal with creating a new array and copying all the values over to this bigger array, just put more in, because you cannot change the length no matter what. There are lists in Java that behave more like Python. You'll learn about that later in the semester. But in terms of primitive arrays in Java, they can only hold one data type. They can only have a fixed length. You must keep those two things in mind, as those are very key differences from Python. But other than that, they in a lot of ways behave like lists. But yeah, that about does it for chapter 2. We went over if-else statements and else-if statements, switch statements, while, do-while, and for loops, and primitive arrays in Java. So thanks for watching, and I hope this video helped you guys understand your course material a little better. And again, don't forget to look over the PowerPoints, because this isn't meant to replace them. This just is meant as a supplement. Thanks.